Welcome back to College Algebra. In this lecture video, let's take a look at the types of basic or common functions that we are going to encounter. So let me help you make this leap on the concept. So the function notation, this function notation, y equal to f of x, okay, it actually defines a function named f. That is, y is a function of x. Y equal to f of x means y is a function of x. So where is this, how is this actually come about? So I want you to recall the equation of a line. Whenever you learn how to graph linear equation, maybe like a x plus y equal to 3. This is a linear equation, okay, written in the standard form. So if I ever want to graph this linear equation, I can either find 2 points, okay, and plot them on the graph and then draw a line, or I can solve for y equal, okay. So if I solve for y equal and begin to write this as slope-intercept form, move the x over, that will be y equal to negative x plus 3. So what we are saying here is y is a function of x. Okay, that simply means we are now going to replace the y to become a function. Okay, so y is now equal to f of x, or I can put it right here. Y is a function of x. So that means, just imagine the word function is like a machine or like a process, okay? You input an x into a machine or a process, okay, and you output a y. So your y, okay, is now going to become, the y value is now going to become the output, okay? The function, the wording of function simply referring to as a process or machine, okay? So if I will erase this y equal, leave my f of x up here. So what was the equation of y equal now actually is now actually become a function, okay? So we input any x, okay, into my function, and we're going to output, it leads to an output of the y value. So we are changing from saying the equation of the line solving for y into that same equation now. That same equation now has become a function, okay? So think of it like this. Your digestive system, you input something through your mouth and you output them on the toilet, okay? So your digestive system is a function, okay? So you input the food and you output on the toilet, all right? So rather than having y equal, rather than solving for y equal, okay, that the equation part of that y equal is now going to become a function of using x. So the reason why it's called f of x, because I'm using variable x. If I ever want to use variable z, then we will just say y is a function of z, okay, because then I will be using z for the variable, okay. So that's the leap. Go from solving for y equal, having a linear equation. The key word here is equation, to changing the word equation to a function. Okay, y is a function of x. So every time when we see f of x, we're thinking about that f of x is replacing your y equal. Okay, so rather than having y equal, now we are having f of x equal. Okay, still, so we're just changing names. Don't call them equation anymore. We call them the word function. Okay. All right. Now, before I begin to graph some of these types of common functions, okay, let us fix our setting in the graphing calculator. All right. The quickest way I know how to fix everything inside your graphing calculator, so we can all have the same setting, is go to the word memory right above the plus sign, color coded. So if you press second plus sign, press number 7, reset, number 2, default, and press number 2, reset. So you go back to, you actually go back to default settings. All right, so once you see this, you can press clear. Now, a couple of things I want you to check. I want you to go to y equal. Make sure there's nothing under anything that says y equal. All right, so this is where we will type in our function at. All right, so rather than having y equal, now what I'm entering, the equation part of the y equal, is now called a function. Make sure your plot 1, 2, or 3 is not highlighted. If it's still highlighted, look like this, I will need to highlight the word plot 1 or plot 2, press enter to actually turn the plots off. Okay, if you have any equation in here, make sure you clear them all out. All right, press the word window right next to y equal. Make sure you're on the standard window, -10 to 10 for both x-min, y-min, x-max, and y-max. Okay, the scale is 1 at a time. All right. At the same time, though, above the word window says table set. Press second table set. Make sure your table starts at 0. Your tab is 1 at a time. Your independent, which we talked about this before, is your x value, is on auto. Your dependent variable, which is your y, is also on auto. Okay. So make sure you actually go back to default setting. All right, so here we go. This is one of the most important objective because this objective sets a tone for what's to come in this course. So the general form for a linear function, so we don't call them equation anymore, for a linear function is f of x equal to mx plus b. We used to call them y equal to mx plus b. Since I'm changing my y, since my y is a function of x, we begin to use f of x equal. All right, m is your slope, b is your y value of the y-intercept. So a lot of students know what linear function or a linear line looks like. It's simply just a straight line. So the most basic one is f of x equal to x to the first, 1x to the first power. So under my y equal, I'm simply going to just press x right here and press graph. All right, so here is my linear function. So if you look at this linear function over this straight line, let me turn it off. All right, I kind of mentioned, I draw a straight line for you before. I draw a straight line for you before and asking you what the domain and the ranges are. Okay, so the straight line I drew in the previous video were the linear function. So I'm going to add my arrows on here. All right. So I need you to memorize, okay? I need to memorize what the common or basic function looks like. This is a linear line. All right, quadratic function. The quadratic function actually always produces what we so-called a parabola. All right, the general form or the standard form is called the f of x equal to ax squared plus bx plus c. So the most basic look is simply f of x equal to x squared. So I'm going to go back here, go back to y equal. All right, press a right arrow key. So that will be x to the second power. So some of y'all's graphing calculator, when you press the exponent key, the caret key, it will actually display as x with a little box. All right, so inside the box, you press a 2. But once you type in the 2, if you want to type something else besides the exponent, or if you want to type in the next term, you need to press the right arrow key to actually move your cursor from the exponent downward. All right, it's a U shape. Quadratic equation always gives us the parabola, which is a U shape. Here we go. All right, I'm gonna purposely draw my arrow key, draw my arrow right there. All right, rational function. So here we go. Things gets complicated from here. All right. Both of these examples here are rational function. The difference between these two common or basic graph is the exponents. Okay. So rational function has a generic form of 1 over x to the n power. Okay. The 1 on the numerator simply implies your numerator is a constant number. It's a constant. Okay. There's no variable up here. It's just a constant value on the numerator. All right. So the x to the n power, if n is odd, then your picture, your graph will always look something similar to this one right here I'm going to draw. If n is even power, then the picture will look something like this one I'm going to draw for you. All right. So if you're ever walking down the ice cream aisle at the grocery store, there's a lot of different flavor, okay, of ice creams, plus the other little ingredient they put in there. Okay. It's not just strawberry. Okay. It's not just strawberry ice cream. It's strawberry with something else. It's not just chocolate ice cream. It's chocolate with caramel. Okay. So those extra ingredients is what makes this course actually a little bit even, made this course a little bit more complicated. Okay. So right now, what I'm trying to attempt to do here is to show you or to identify all the basic flavor of ice cream. Okay. In other objective, I will actually begin to add extra ingredient. Okay. But that's later on. But right now we need to know what the most common or basic, okay, graph looks like for all these functions. And then we can begin to add extra flavor, okay, to the point where you cannot even recognize that what type of function it is, okay. But so these are common core, okay, of the graph, or the basic flavor of the ice cream. Okay, think of that way. Hopefully, it'll make a little bit more sense. All right, so I'm going to go back to y equal, clear out. I'm going to type in 1 over x, 1 over x. Oops, sorry, typing the wrong button. Second quit. 1 over x. Okay, it's one term over one term, so I don't need extra parentheses. So this is what 1 over x looks like. Doesn't look much because my window is set at -10 to 10. So let's play with this a little bit. I'm gonna show you how to do this. Okay, I'm gonna squeeze my window. I'm gonna squeeze this window from the left, from the right, from the downward, and squeeze it from down up. I'm gonna make everything tighter, because if I make my window a little bit smaller or tighter, hopefully my graph will pop out a little bit. So I'm going to change my x minimum to -5, x maximum to 5, squeezing from left and right, and squeezing from up and down. So make the y minimum to -5, y max to 5. So in that case, my graph will pop out a little bit better. All right, so let me take a picture of this. So this is what 1 over x looks like, where the exponent is odd. All right. Now, as I mentioned before, whenever we're dealing with a fraction, denominator can never equal to 0. So this x down here should never equal to 0. And that is called the restriction on the domain. Okay. What my denominator cannot be is called the restriction on the domain. So if I go look at the table, all right, table is right above the word graph. If I press second table, when x equal to 0, it's going to give me an error message because my function is not defined when x is equal to 0. Okay, that's called the restriction on the domain. So by looking at this 1 over x squared, my denominator can never equal to 0. So all I'm going to do is set my denominator not equal to 0 and solve for the x. So if I take a square root on both sides, I should get positive and negative 0, which is x still cannot equal to 0. All right, so let me grab this picture real quick. So I feel a little bit safer to actually put my x squared in the parenthesis now because I got other operations on the denominator. So I'm going to say 1 over per open parenthesis x raised into the second power. Okay, so if I have a little caret key up here, okay, just be careful. You know, anything else you want to type afterward, you need to press the right arrow key to come off the exponent. And this is what it looked like. Okay, so this is actually the window that I set earlier. Okay, so if you ever want to go back to standard window, press the word zoom and choose number 6. Go back to the standard window, which is from -10 to 10. But this is a good picture I can use. So I'm going to use it for right now. All right, so here we go. 1 over x squared. All right. So again, the 1 on the numerator simply implies the numerator right now is actually a constant. So if my numerator would be like a variable x over x squared, then this problem changed. Okay, still a rational function, but it's a rational function with other flavor involved. Okay, so it can actually lead to, you know, a whole different taste. Okay, if this is a chocolate ice cream with extra flavor added into it, we can still taste a little bit chocolate, but it's still the combination of ingredients can actually lead to what tastes like something else. Okay, that's why this class is complicated, because anything we add on to our basic function, okay, it actually can change the look of the graph. So that's why it's very important that we now identify what the basic graph looks like. Okay, then we can begin to add extra flavor. Absolute value function. Okay, you probably learned about how to solve for absolute value equation before. So rather than having an absolute value equation, that equation leads to a graph. Okay, and that graph we call them as a function. So to graph, so I'm going to go back to standard window real quick, press zoom number 6, and then go back to y equal. All right, I'm going to clear that out. Absolute value of x, press math. Go to press the right arrow key, highlight the word number 1, ABS, absolute value, press X, close parenthesis. All right, absolute value function, give me a V, like the peace sign, peace, a V shape. All right. So this is my absolute value function. Oh, don't forget my arrows. This is going that way, that way, that way, and that way. Let me put my arrow in there. There you go. There's a V shape. All right. Cubic functions. Cubic function is actually considered as a polynomial function. So is the parabola, quadratic. They all classify under as a polynomial function, which we'll talk about that in a whole different part of this course. So I'm just going to graph the picture, let you take a look at it. That will be x to the 3rd power. It look like this. Okay. So polynomial function. So this x to the 3rd power is a polynomial function. So if I ever have a polynomial function where the exponent is x to the n power, f of x equal to x to the n power is considered as a polynomial function. If the n is odd, then the picture will always look like this one. Okay. If the exponents are, you'll always look like that. If an exponent is even, it will always look like a U-looking shape. My pen is acting up, excuse me. N is even power. It'll always look like a U-looking thing. Okay. Now, of course, with the exception of the polynomial function, with the exception of linear. Linear function is actually a polynomial function, but linear function has its own look, which is a straight line. That's why they are considered as a polynomial function with exponent that is odd, but this is the only odd power that look different than other odd exponents. Okay, all the other odd one will always look something like this. All right, radical function. Okay, both of these are radical functions. One of them is a square root, one of them is a cube root. So radical function always has the form of nth roots of x. So if the roots is odd, okay, it will often look like this picture here I'm going to draw. If the index or the roots is even, it can always look like this. Okay, this picture right here I'm going to draw. Now, if I have a function that is saying square root of x squared minus 9, then that will look differently than either one of these. Still a radical function, but now there's a radical function with a added flavor, added ingredient, because I have an x squared now. Both of these here right now is x to the first power. So you see anything we add to these basic function, okay, it actually changes. It can actually change the look of your graph. I will talk more about adding our ingredient in a different objective. So let me show you what this picture looks like real quick. All right, square root. I'm just gonna go to press second x squared. That's a square root. And inside the parenthesis or inside the box, if you have a little box there, just press X and close my parenthesis and press graph. This is what it looks like. Here we go. All right, let me draw the cube root of x. So for cube root of x, I'm just going to say math, choose number 4, cube roots. Inside the parenthesis, I put my x in there, close parenthesis, then press graph. It will look something like this. Okay. Let me draw my arrows. So here we go. These are our basic functions. Okay, I need you to memorize them. There's actually another function I didn't draw here that is actually quite common. It's called the constant function. I'm going to write it down just in case if I ever forget later on to mention it. Constant function. All right, constant function is actually referring to as your horizontal line, where your function, your f of x, is simply going to equal to a numerical number. It's actually going to equal to a number. So if I have, for example, like f of x equal to 3, okay, it's almost like saying y equal to 3. So as you can recall, y equal to a number is a horizontal line. So right now we call horizontal line as a constant function. So in my graphing calculator, if I go to y equal and simply typing 3, that will actually give me a constant function. Okay, what is constant? Why I use that word constant? The numerical value is considered as a constant. It's the constant term, which is always a last term, okay, of a polynomial. It's actually a term that where the variable has exponent 0. Okay, so if you just see a number standing alone, that's considered as a constant function. So the word constant also referring to the y value remains constant, remains the same, which is 3. Okay, that's what we call them, the constant function. This is just a little example of it. I mean, this number can be a half, can be a 0.5, okay, but the y value will remain constant. The x value changes. So let me ask you a good question, and I always ask students this question. If y equal to 3 is this horizontal line, then where is y equal to 0? Where is y equal to 0? Where, E-R-E. Where is y equal to 0 at on the graph? Okay, I want you to think about this, okay? All right, so here are our basic common graphs. So I put a little arrow key so we can begin to think about in terms of left to the right, what is the domain, okay, of our function. So for linear function, I mentioned this before, the domain is always from negative infinity to infinity, right? The right side keep on going right, the left side keep on coming from the very, very, very left, coming from very left. Again, the left side is keep on going down, 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 down. The other side is also keep on going up, up, up. So my range is negative infinity to infinity. All right, for parabola, for quadratic functions, the domain will always be from negative infinity to infinity. Because if you look at this arrow I put here, okay, I know this arrow is pointing upward, but at the same time, though, my x value is actually keep on going to the right as well. The other side is also pointing upward, okay, but the y value from left to the right is actually coming downward, okay. Where does it coming downward at from the left direction? It's actually coming from very, very left, which is from negative infinity. So your domain is actually negative infinity all the way to infinity. All right. So for your quadratic functions, okay, the domain is always going to be negative infinity to infinity because one side keep on going left, the other side keep on going right. All right. But when we're thinking about in terms of interval notation, we always got to think from left to the right. Range will vary. The range of the quadratic function will actually change. So we will talk about that in a different video. All right, rational function, okay? If you look at this arrow right here, okay, thinking about from left to the right, it's coming from very, very left. So that means my domain got to be from negative infinity. All right, it's coming from very, very left. All the x value coming from very, very left. It's keep on coming to the right, but as it approaches x equal to 0, which we already know x cannot be 0, which is my restriction on the domain. So you can get as close to 0 as you want, but you just can never actually equal to 0. So it can be negative 0.00001, okay, but it's not quite 0 yet. So my domain got to be from negative infinity, all the x value coming from negative infinity, approaching to 0, but not including 0. That's why I put a parenthesis on the 0. All right. Union, or my domain is now going to be on the other side of 0. So 0 is right here. My domain, my x value exists on the right side of the 0 and also exists on the left side of 0. It just can never actually equal to 0. So on the right side of 0, okay, my domain exists. So the way I'm writing my domain here, it got to be on the right side. The other part of the domain got to be starting from 0 and keep on going to the right to infinity. All right. So this one will be exactly the same way. I'm not talking about the range because the range also changes for both of these rational functions. This side keep on coming from the left. This side keep on going to the right. But as my domain coming from, as my x value coming from the left, it will actually get as close to 0 as I can, but it's never going to be quite exactly 0. So the domain for this 1 over x squared will also be this. All right, there's actually a lot about rational functions that we're going to talk about later on as well. So right now I'm just going to quickly write down the domain, okay, with the restriction, with the restriction already written. Absolute value function behave a lot like the parabola, the quadratic functions. Okay, so the domain is also going to be from negative infinity all the way to infinity, because this arrow key is pointing up, also left. This arrow key pointing to the right, also point upward. So think about domain from left to the right is coming from negative infinity, keep on going to the right. So every time when I say domain, you think about all the x values that are on the line. You're thinking about the width of the graph. All right, basically all the polynomial functions, okay, have the same domain. Actually, I think it is that all of them are having the same domain. Because this side is keep on going down, but it's also coming from the left side. This side is keep on going up, but it's also keep on going upward. So the domain for the cubic function is always from negative infinity to infinity. The range is also going to be the same. Keep on going down, 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 keep on going up, up, up. So from down and up is coming up from negative infinity and keep on going upward. All right. Now for radical function, a lot of times, especially square root, okay, square root function, a lot of time for us to know where the domain is where's the domain gonna begin, we can simply set what's inside the radical equal to 0. And that will tell me where the domain will begin. All right, so apparently for this particular problem, the domain will actually start, okay, at 0, 0. So my domain is starting from 0, keep on going to the right. Parentheses or bracket for my 0. Gotta actually use bracket because the 0, 0 is actually a point on my graph. So for any point, for any value that is actually on the line, I'm always using a bracket. All right. Now, so that means there's actually nothing. The graph never existed to the left of my 0. Okay, 0 is the starting. For cubic function, though, it's actually both arrows pointing to the right or the left. So from left to the right, for this particular cubic function, the domain is actually from negative infinity to infinity. And it's very obvious what the constant function will always be. The domain will always be the same, which is from negative infinity to infinity. Keep on coming from left and to all the way, keep on going to the right. Of course, now the range will change, right? The range will change because it depends on what this numerical value is. So right now, my y is equal to 3 or my f of x is equal to 3. So the only range, the only y value I have is 3. So I cannot use interval notation to describe just one value, one solution. So that's the reason why I have to use a set notation. And inside the set notation, my range is a single value, which is 3. All right. So in this lecture video, we talk about the different types of common or basic functions. Okay. I need y'all to memorize what they look like. Okay. The more you memorize them, the easier. The easier this course is going to be. This course is not just about giving you a function, put in the calculator. Okay. It's a lot more about looking at what the function, what type of function it is, and what extra ingredient is being added to the function. Okay, so we will begin to talk more and more about these ingredient that is being added to it at the later on objective. Okay, that will conclude this video. Thank you for watching.